So today we are going to look at lesson 7-3, logarithms. So we're going to graph logarithms later, but we did graph y equals b to the x in 7-1. And so we're just going to take, actually the log and this are the same thing. So a log is just another way to write an exponential equation. And so again, it's basically a process. So as I had mentioned before, most of this unit is about processes that you have to study. So you are going to have to study this process. The process is easy, but if you don't go back and restudy, you're going to forget all the different processes that we go over. So this is read log base b of a equals x. This base b must be greater than 1. It can't be negative, it can't be 0, it can't be 1. And then for a is called the argument. Not because you're arguing with somebody, but it's just a mathematical term. Argument. And so we're basically taking log of some base of this thing called the argument is going to give you a value. Now to put it in exponential form, all you do is take the base of the log, and notice that this is a sub, meaning it's dropped down below. The log and the a are on the same line. The b should definitely be shown as significantly dropped down, so it's a sub number. If it looks like that b is on the same line as the log, you'll get marked wrong. So if you ignore the log and just cover that up, it looks like b to the a. So we're going to take that b, and it's going to be the same as the base in our exponential function. But then we're just going to switch these two around. We're going to switch the a and the x. So it's read b to the x is equal to a. So this and this are the same thing. This and this are the same thing. Notice we have b to the x, b to the x. So instead of y, I just happen to have a this time. So then, I'm going to make these bigger so you can see. We're just going to write these in exponential form. So there's really nothing, you're not finding a value, you're just converting this to its exponential form. And again, the exponential form and the log form, this is the log form, are the same thing. They're just two different ways of writing the same thing. So I'm going to do the first one for you, and then you're going to do the rest of these, well, a lot of them on your own. I'll have you break and pause the video here and there and then check your work. But we're going to take this base right there, 3, and then we're going to switch the 9 and the 2. So 3 to the second is equal to 9. And isn't that a true statement? 3 squared is equal to 9. And that's it. You're not supposed to, find a value for 3 squared. You don't go any further. That's it. So then what I want you to do is pause the video, and I want you to do 2, 3, and 4 on your own, and then check your work. All right, so for number 2, you're going to take the 6 and then switch these two. So 6 to the third is equal to 216. For number 3, I'm going to take the base of 7, and you're going to switch these two. So 7 to the 0 power is equal to 1. You might think that there's something wrong with that can possibly be 1, but remember, anything to the 0 power is 1. And then number 4, take the base of 2 and switch these. 2 to the 4th is equal to 16. All right, so I had you pause there at 4 because starting with number 5, we have this fraction, and so it tends to freak you out, but the process is still the same. You're still going to take the base of 4, and you're going to switch these two. So 4 to the negative 2 is equal to 1 over 16. And if you think about it, 16 is 4 squared, and if we get rid of if we move it from the denominator to the numerator, this 4 squared will move upstairs and the exponent becomes negative. So 1/16 is equal to 4 to the negative 2. All right, you try number 6 on your own, so pause the video and then check your answer. So you're going to take the base of 9 and switch these two. So 9 to the 3/2 is equal to 27. Again, you'll be thinking, well, I have no idea if that's correct. Remember, if you have a fractional exponent, if you cover that up, it looks like 9 cubed. And then this represents the root of what we're taking because it's going to be a radical. So we've got 9 cubed. And because this denominator is 2, the index here is 2. So we've got a square root of 9 cubed. If this index were 4, we'd have a 4th root of 9 cubed. If this were a 5, we'd have a 5th root of 9 cubed. So let's think about it this way. What's the square root of 9? It's 3, and 3 cubed is 27. All right, so then as we reach number 7, now we're going to take the exponential form and put it into log form. So just a word of caution, I have taught this to you so that your log is on the left. If you're ever given a problem where the log is on the right-hand side, I would definitely advise you to, switch the left and right side so that your log is always on your left when you're doing this conversion. Same thing's going to occur if you have exponential form and I ask you to put it into log form. I'm teaching it to you with the power on the left. So if you're given a problem with the powers on the right, switch the left and right side so your power is always on the left. All right, so we are going to write log, and this is going to become our base, so make sure it's a sub number, and then we're switching these two. So we're going to take the log of 196, log base 14 of 196 is equal to 2. So again, I kept the same base, so that becomes the base of my log, and then I switched these around, 196 and 2. So you go ahead and do 8, 9, and 10 on your own. Don't let the fraction bother you. Pause the video, check your work. All right, so for this one we've got log, and I'm going to keep this as my base, so base of 3, and then we're going to switch these two. So I've got 81 and 4, and there's an equals in between. All right, then number 9, I'm going to write log, and this becomes my base. And then I'm switching these two, so 12 and 1. And you're going to find out when we do properties later this week that anytime you have a base that agrees with the argument, that the value will always be 1. So if I have log base 5 of 5, the value will be 1. Log base 36 of 36, the value will be 1. And then number 10, don't let that fraction bother you. We're still going to do log. This is our base. And then we're switching these two. So log base 36 of 6 is equal to 1/2. All right, so you go ahead and do 11 and 12 on your own, and then we'll actually use it in algebra here on the other side. So pause the video, do 11 and 12, check your answers. All right, so for 11 you've got log base 2, and you're switching, so you got 1/8 is equal to -3. And then for number 12, log base 8, and you're switching, of 16 equals 4/3. Let's look at the back page. All right, so for our back page, before we continue, let's talk about what the common log is. So let me make this just a smidge bigger. Okay. So you might want to highlight this, but a logarithm with a base of 10 is always called a common log. So I would highlight that and circle that base 10. So if you looked at this right here, you have a log base 10 of x. Typically you won't see it written with a base of 10. It'll just be written as log of x. The base 10 is going to be missing right here. So oftentimes you'll see me put in a little 10 here just so that I can remember that, oh yeah, my base is 10 and not x. So the button on your calculator, if you look on the left-hand side of your calculator, you will see log for log, and right underneath it, ln. That button on your calculator that says log assumes a common law or a common base of 10. So you can only use that button on your calculator if you have a log with a base of 10. So I'm going to show you how to algebraically use what we just learned combined with lesson 7.2. So we're going to combine 7.2 and 7.3, and we're going to come up with a value for this log right here. So there are three steps to finding the value. So I'm going to have you write them out here first. So step one, you are going, if it's not an equation and it doesn't equal some variable like we have here, we don't have an equal sign, you're going to set it equal to x. So the first thing you're going to do is equals x. Then part two is you're going to put into exponential form. So you need to take this out of log. So my base of my log is 7, and I'm switching these two. So 7 to the x is equal to 49. And then your last step is going to be to solve by finding like bases, if at all possible. If you can't get like bases, then I'm going to show you how to do it on your calculator. So same thing that we did on Thursday, you have a base of 7 and a base of 49. I can exchange the 49 for 7 squared. So I get 7 to the x is equal to 7 squared. And because I have like bases, I can drop those and just set the exponents equal to each other. And this one happens to solve immediately. So that means that the value of log base 7 of 49 is equal to 2. And we were able to do that without our calculator. So try that with 14. So I want you to do, let's see, 14 through 16 first. We'll just start there. Pause the video and then check your work. So following the rules, we're going to set this equal to x, and then I'm going to put this log into exponential form. So the base is 3, and I'm switching these two. So 3 to the x is equal to 27. Then I've got to get this into a base of 3, so it matches this one. So we've used 27 a lot. So at this point, you should know that 27 is 3 cubed. If not, you can prime factor 27 off to the side here, and you can see that it's 3 cubed. So then we can drop our bases, set our exponents equal to each other, and it immediately solves it for us. So then 15, I'm going to set this equal to x. Now this time I don't see a base. So if I don't see a base, remember it's understood that it's a base 10. So I'm going to take that base of 10, and I'm going to switch these two. So 10 to the x is equal to 100. This is called a power of 10. Anytime you have a 1 and multiple zeros behind it, it's a power of 10. The number of zeros tells you what we're going to raise 10 to. So because I have 2 zeros, that is 10 squared. Now I have like bases, so x must be equal to 2. So log base 10 of 100 is equal to 2. And then the last one I gave you, you're going to set it equal to x, put it into exponential form, so 12 to the x is equal to 1. Now this one I cannot make these into like bases. However, logic reasoning says that 12 to what power is 1? Well, anything to a particular power is always 1, and that power is 0. So if I take 12 and raise it to the 0 power, I will get 1. That's the only way to get 1, and so that's kind of a logic reasoning one. All right, so let's look at 17 through 20. So again, the same thing, but you might end up getting some fractions in there. Don't let that bother you. We've already dealt with things like this where we have fractions. You turn this into a base of 9, which is 9 squared, and push it up into the numerator, and it makes it 9 to the negative 2. So go ahead and try 17 through 20, pause the video, and then go back and check your work. So I'm setting it equal to x. Exponential form is 2 to the x is equal to 64. 64 can be exchanged for a power of 2, so that's 2 to the 6th. And then you can drop your bases and set those exponents equal. Number 18. Now it should be a clue to you that when I set this equal to x and I put it into exponential form, so these get switched, 3 to the x is equal to 243. So it should be a clue that if that's my lower base, perhaps this has a 3 in it. So all you have to do is just take it off to the side, and you've got use of a calculator. Take 243 and divide it by 3 on your calculator. You're going to get 81. That should become more familiar. 81 is 9 and 9, and each of those 9s gives you 2 3s. So I actually have 5 3s altogether. So 243 can be exchanged for 3 to the 5th, 3 to the x, drop your bases, set your exponents equal, and you do get x equals 5. Number 19. So I'm going to set that equal to x. And then I'm going to put it into exponential form, so 9 to the x is equal to 1 over 81. Now 81 can be switched for 9 squared. You could have changed them both into 3s, but that's more work. And then we want to put that 9 squared up into the numerator, which changes the exponent to a negative. So we get 9 to the x is equal to 9 to the negative 2. And so now you can drop your bases and set your exponents equal. Last one is 20. So for 20, we're going to set it equal to x, put it into exponential form. 64 to the x is equal to 4. So you want to ask yourself, here's my smaller base, can I break 64 into multiples of 4, or products of 4? We've worked with 64 a lot. At this point, you should know that that is 4 to the 3rd. It is raised to the x, and that's equal to 4. Now don't forget that this 4 has an exponent of 1, and over here we have power to a power, so we really have 4 to the 3x is equal to 4 to the 1st. Then we're going to drop our bases and set our exponents equal, and this one does require a little work on our behalf. And so we get x is equal to 1/3. All right, so change of base. Change of base is used when you cannot get, try to make it a little bit smaller, when you cannot get like bases. So for instance, sorry to make you a little nauseous there, if I look at number 21 right here, if I were to put this into exponential form, let's not look at 21. Let's not look at Let's look at instead number 23. Number 23 is the only, starting with 23, 24, and 25. Those 3, I would not be able to find like bases. So let me just prove it to you. So if I set this equal to x and I put it into exponential form, I get 2 to the x is equal to 54. 54 is not made up of solely of 2's. So although I can divide 54 by 2, it's not made up of only 2's. So we would not be able to get these into a like base. So instead, oops, let's try to erase that. And now it won't let me erase it. Not the one I want anyway. Well, let's see if I can do it. It still won't let me. All right, well. I don't know what I just did. Anyway, I'm just trying to get that to go away. We'll have to ignore it later. All right, so some logarithm aren't easy, so we're going to use this change of base formula. So again, it's a process. So all we're going to do is we're going to take this log base b of anything of a. We're going to take the log of the argument, so just log of a, we're going to ignore this b, and we're just going to write it exactly as you see it here, log of a. Divided by. Now the way I've written this, notice that there's no base here, so the base is assumed to be base 10. That means that I'm going to be able to use that key on my calculator in order to find the value of the log. And then for the denominator here, we're going to just take the log of b. So that base is going to get brought up onto the same line as the log b. So again, all I did was take log of a, put it in the top, log of b, and put it in the bottom. Notice that there's no base here, so it's log base 10. So I'm going to prove to you that it works. For instance, I'm going to look at number 17. So for number 17 right here, if I were to do a change of base, so I'm going to make this bigger so that we all can see. There we go. So if I were to do change of base, okay, I would take log of 64 and divide it by log of 2. So if you go into your calculator and actually put this into your calculator is going to actually put opening parentheses right here. As soon as you hit that log button on your calculator, it does open parentheses. So when you put 64 in there, you have to make sure you close the parentheses. Don't forget to put divided by, so you have to hit the division button. And then when you hit this log, it's going to again do open parentheses. Just make sure you close them. And so if you do log of 64 divided by log of 2, you do indeed get 6 for your answer. And didn't we say that the value of x is 6? So this was one way, this was another way. So the question begs, why can't I just do this every time on my calculator, not worry about the math? Because you've got to understand the algebra, because you can't always use your calculator for everything. So let's go back here, and I want you to do 21 and 22 on your own. And then, so pause the video and see if you have put it in your calculator correctly before you go on and do any more. All right, so your change of base for this one is log of 64 divided by log of 16. And you get 1.5. Probably means, if you get a terminating decimal or just an integer, probably means you could have done it algebraically. Then for 22, this is going to equal log of 32 divided by log of 8 equals 1 point, and this one goes 1.6666666 forever. So I'm going to round mine to 4 decimal places. So 1.6667. And so this becomes an approximation because we just rounded it. So now, for this one, we're not going to do it this way. We're going to do it with a change of base. So it will equal log of 54 divided by log of 2. So punch that into your calculator. You're going to get approximately equal to 5.7549. All right, so then I want you to pause the video. If you've got that set, pause the video and do 24, 25, and 26 on your own, and then check your work, and then we're done. So for 24, you would have log of 294 divided by log of 10. And that's going to give you approximately equal to 2.4683. 25 equals log of 136 divided by log of 4. And that is going to approximately equal 3.5437. And finally, the last one, don't let the fraction freak you out. You just put it in your calculator, log, parentheses of 1 divided by 36 over log, parentheses 6. And that equals -2. So that one you could have done algebraically. All right, that's it. It's pretty simple. Good luck. Complete all of your homework.